From that Plinton tablet we found, the Babylonian knew about the Pythagorean triples. Uh, the Pythagorean triple means that the combination of these three numbers, especially like integer values, satisfying that Pythagorean theorem. So x squared plus y equals z squared, like that. But when we talk about the Pythagorean triple, most likely it's kind of intuitive ones, which means those three numbers x, y, z's are relatively prime each other, which means there is no common factors for all three numbers. So the most famous one and simplest one is 435 or 345. It depends on how you look at it. But the meaning of intuitive is if you make it double for all these three numbers, like 8, 6, 10, then that is also the size of right triangle, like 6, 8, 10. By the similarity, we can easily could see, right, why these three numbers is also satisfying the Pythagorean theorems like that, right? Then in that case, we don't think that Pythagorean triples as the intuitive ones, because if we have that, then we can always make it easily, right, for that. So what we are looking for is the intuitive ones. So next one, the easiest one is 5, 12, and 13. Okay? Please check by yourself. So you cannot get it from this one, right? It should be starting its own way, right? And of course, all the multiples of this is also satisfying that. And even we are not thinking about non-integer values for the size. Still, you can get it, right? Make it half of this one, then it's 1.5 to 2.5. That's good kind of Pythagorean triples, right? Satisfying that Pythagorean theorems, right? So when you're talking about, but this one can be get from this one too, right? Still, okay, make it half of this. So whenever we got these intuitive triples, we can get all the other stuff. Then we are not thinking about this one when you're thinking about the intuitive, primitive, Pythagorean triples, right? Only those types of one. Then the Babylonian already knew about how to find it, and they make even table like that, right? So we have no idea how many of them they use, but we figure out they already have this kind of formula, so why not? They could make it whenever they need it. Okay? So let me just explain how to get this one. I mean, how this one is working, right? So all we need is just follow the Pythagorean theorem for and that one. So if x equals m square minus n square. At this moment, m and n's are just integers, and because x is the length of one side of triangle, it must be positive. So because of the nature of the form, m must be greater than n. Right? We don't need to mention that, right? And it says different parity. It turns out that we needed to get these primitive Pythagorean triples, right? But eventually it turns out one of them must be even, then the other one must be odd, right? For m and n's, right? Okay. And of course, m and n should be relative prime each other by that one. Okay, so but just that. So if we choose those mn satisfying those conditions, then x equals m square minus n square, right? So if we make it square, then it's going to be m to the fourth minus 2 times m square n square plus n to the fourth, right? And because y equals 2mn, make it square, is 4m squared n squared, right? And z is m squared plus n squared, so when you make it square, it's m to the fourth plus 2m squared n squared plus n to the fourth. Now let's look at this. What is x squared plus y squared? X squared is that, and y squared is this one. So when you look at those midterms from there and with this, both of them has m squared and squared, right? But one of them is negative 2, the other one is positive 4. So when you add them, we are going to get m squared plus 2m squared n squared plus n to the fourth, and that is exactly same as z squared, right? So that's the kind of proof why those combinations are good for satisfying these Pythagorean theorems. Okay? So for the purpose, right, practice purpose, let's say in that tablet, it shows for those choice of m and n, we are going to get one of these primitive Pythagorean triples, right? Excuse me. So it's actually simple. X should be m squared minus n squared, which is 81 squared minus 40 squared. Okay, and I will calculate is 51 minus, 61 minus 1600 and 4961. Okay, and y is m2mn, right? So it's 2 times 81 times 40 is 6480, and z is m squared plus n squared. So once again is 6561 plus 1600. Now is 8161, right? Okay, then that Pythagorean triple should be a combination of those, right? So like 4961, 6480, and 8161. So please check by yourself that 4961 squared plus 6480 squared equals 8161 squared, right? At least, if you make it square on the right hand side, the first unit it should be 1, right? 1 times 1 is 1, but this one becomes 0 and that one becomes 1. So when you're adding them, and it's 7, right? But, okay, you check by yourself. And another thing from there is somehow they have to know that one of the famous algebra formula, right, we have, and we already used that one today. So let's just look at that case, which is a plus b times a minus b equals a squared minus b squared. Right? When you use distribution law, it's very easy to find and prove, right? So that proof is nothing, right? It's very easily we can show it. But how about geometric explanation of it? Okay, so it's like this. Let's say we have a square, and each side a, because it's square. And let's say b is smaller than a, okay? Because we want to handle as a positive numbers. So then we can choose any portion at the corner, like it's a b and b, right? Another square, right? Like that. So a squared minus b squared means we want to remove that, right? Like this. So this right hand side is the area of this shape, right? From there. Okay. So that's a squared minus b squared. Then how can you get this a plus b and a minus b there? Okay. Everything is just cut out this much, right? Okay. Then when you look at this portion, the original length was a, but this was b, so that is a minus b, right? And when you look at this one, it's exactly the same as that case, so it's also a minus b. So this length and that length is the same, right? Congruent. So let me cut out this portion and place over here, right? So that can be shown like this is a minus b, and that is a, right? And this bottom part is replaced over here, right? After rotation, right? So that A minus B portion go over here. So they are matching exactly like that. And how much this? That is exactly B, right? So that is B. Okay? So altogether, we have A minus B for the heights, and the base is A plus B, right? This is A plus B. So we don't touch anything, right? The area for that should be same as area of this one, right? So that portion is A square minus B square, but area for this one is A plus B times A minus B, right? So that's the geometric explanation of it. Okay? And somehow the Babylonians should know about that formula, or at least they could handle that one. So this is another example of Babylonian tablet shows. Let's say we have a triangle inscribed in a circle, and the condition is it's isosceles triangle, which means two sides length are 50s, right? And the third one is 16. And they're looking for, then what is the radius of the circle? Okay, so let's say radius is r, then everything is like that. That is r, that is also radius, and that is also radius, right? But the only given information is just the length of each side like that, right? So let's say that height is x, and try to get some equations, right? System of equations, and get this r and x values, right? Okay, so for that setting, let's say this is isosceles triangle, so this one is perpendicular to 60, then that two triangles are congruent each other, right? In geometry, that means these two sides are congruent each other, so it should be 30 and 30, right? So let's look at one of them from this. And this is 50, and the height is r plus x, right? And the base is 13. Then this is right triangle. So by the Pythagorean theorem, it's not we are calling Pythagorean theorem, but Babylonian knows it, right? They knew it about it. Okay, so it's r plus x squared plus 30 squared equals 50 squared. Then it's r plus x squared equals 50 squared 2500 minus 900, which is 30 squared, right? So it's going to be 1600, which is 40 squared. So technically, r plus x must be plus minus square root of 40 squared is plus minus 40, but once again, r plus x is the length. Okay, so we cannot accept negative, and r plus x must be 40. Okay, so skip that one in your mind. Next one is, let's look at that small triangle over there. And let me just look at either way. Okay, but so from there, this is r, and that is x, and the base is 13, but that is also right triangle. So from there, we know x squared plus 30 squared equals r squared, which means r squared minus x squared equals 30 squared, which is 900. Now, let's look at here. It's r squared minus x squared. It looks like a squared minus b squared. So we can convert that form to r plus x times r minus x, right? And that is 900. But we just find out r plus x must be 14, right? So this must be 14. So let's combine them together. So 40 times r minus x equals 900. Then r minus x equals 900 over 40, which is 90 over 4, which is 45 over 2, just about that much, right? So from these two, we can calculate r plus x equals 40, r minus x equals 45 over 2. So when you add them side by side, the left-hand side becomes 2r. You have to cancel out the x's. And the right-hand side is 40 is same as 80 over 2, right? So altogether, 125 over 2, right? So r must be 125 over 2 divided by 2, which means 4, right? So that is the radius of that circumcircle of the triangle.